Thanks, Hannah Sutke. All right.
Plastic bag so it doesn't stink up the class.
Please take out your calculator from yesterday. Get those expected counts. Or we entered our, of course, now that I'm on video, I'm going to be like misspeaking all the time here. What we did yesterday is we entered our observations. And we're, ladies and gentlemen, we are always putting in our counts. So I'll put in a highlighter right now. We entered these values into our matrix editor. I showed you how to get into your matrix editor by hitting second, x to the negative first, arrow over to edit, go to A and put in your 3x2 matrices. Watch out for the totals here. You do not want to enter in your totals. And we had a total over here, I think, too. Okay? So it was a 3x2 matrix. These numbers should be entered in. You're never entering in proportions. Chi-squared is all about counts. Do we all have that entered in now? And are we ready to proceed? Okay. What we're doing right now, if you noticed, I said, hey, I showed you how to find your expected counts by hand. So we take, again, this row total times the column total divided by the grand total to give you your expected count right here. Okay? We don't have that yet. We didn't write it down. But now I'm showing you how to find it in the calculator. And all tests, you can just go right to the calculator. I showed you the row total times column total divided by grand total for the multiple choice piece. All right, here we go. In your calculator, what I'd like you to do right now is after you do the matrix operations, you're going to head to the chi-square test in your calculator. So go to Stat, arrow over to Tests for me. When you arrow over to Test, you scroll down where you see chi-square test. Not goodness of fit test, chi-square test. Hit enter on chi-square test. Doesn't matter, we'll still do the same, okay? In your calculator, okay, in the calculator you should see, where is that working here? Is everyone at the chi-square test? In your calculator, you should see this. Okay, it should say observed, expected. What does it say under it? Just calculate under that? Okay, do you see these three things in your chi-square test? Does anyone not raise their hand? Okay. Okay. Reminder, we are on video right now. Okay. What I want to, no big deal, but I'm trying to get through the notes so it's not a long video for your classmates to watch. What we did previous to going to the calculator is we did these matrix operations here. Okay? Right? We did this. That's supposed to be a circle. Now we're going to the calculator. In your observed, you should see A. It should look like this. Do you see this? Yeah. Do you see B? Yeah. What we're going to do is we're going to calculate right now, and the expected counts will go right into that B matrix. So everyone hit enter on calculate, and now we get to what we call our side work. So everyone should have calculated. Your side work, what I'm going to write down is I'm going to write my chi-squared value, which is 19.4889. My key value is equal to 5.86 times 10 to the negative 5, which means 0.00006. And then my degrees of freedom is 2. So what did I do first? I did my matrix observation. I went into my calculator, and now I have my side work. We still haven't finished out our conditions yet. want you to do, does anyone need a second? Did anyone else get anything different than that in your calculator? Okay, now what I want you to do right now is I want you to go back to your matrix editor, okay? So hit second x to the negative 1. Scroll over to, or no, you don't even have to scroll over, just go down to B, okay? Hit enter on B, and then hit enter again. Here are your expected counts, okay? Here's your expected counts, so you should be able, okay, I can't scroll over and Becca's here. Can the rest of you scroll over?
Yeah.
Okay, I don't know why Becca's aren't scrolling over. Can you guys read me now your expected counts? So the first one was what?
177.
Point what?
5, 6. No. Or 77 on that.
It's okay, thank you. Okay, 107.
No, 77.
Oh gosh, 77. Let's just do 2 decimal places. So 77.56. Okay, this one is what? It's okay.
No.
Okay, someone else help Eric out.
220.
220 point what? 25. This one is what?
53.4.
This one, the bottom one here is 53 point.
No, the top one.
I'm sorry because I put my pen there. 53 point 4. What's this one right here? 151 point.
75.
Okay, and then what's this one? 612.19. And then this one?
421.8.
Okay. Okay, those whose won't scroll over to see them? I'm just curious. Just two. Like how? So like Becca's, I can't see them. I only see the first column.
Did you use the arrow?
Yeah, I did. So like I just pointed. Oh, now if I do it again. Okay. I'll help you if you can't scroll over. Okay. Okay, again, I am taping right now. I'm trying to get us on track, so please listen up. We did all of that work just to get to our expected counts. What I like about that, rather than calculating it by hand, though, is we also have our test done. Our side work says, hey, we're done actually with the do part. All we have to do with the do part, first we have to do what? What do we have to say about our expected cell counts? They're all greater than 1. Yep, expected cell counts. Greater than or equal to 5. You see them. Yep. You do need decimals in your expected cell. I think 2 is fine.
You know, once you're like done with this, you can cut out all the parts you don't want.
In my video?
Yeah.
Nice.
So like this like awkward gap where no one's doing anything.
All right, I like this timer down here. I feel like we should videotape every lesson so it keeps me on track of like, let's go.
Set a timer.
True, I could do that as
But
well.
if you record every session, the absent kids can actually like act.
Exactly, right? I think that'd be great. So,
Do that college students.
huh?
College students do your record every lesson.
Yeah, yeah. All right, so ladies and gentlemen, we have our expected counts are greater than or equal to 5. We are okay to proceed, but before we proceed, we have to say what is our method? It's our chi-squared test. What are we testing right now? We're not testing goodness of fit, we're testing homogeneity. A friendly reminder that homogeneity is for 2+ populations to see if the distribution for one variable is the same across the population. If they're different, is it a significant difference? Now I'm mad I didn't take all my lessons, like the whole year, right? If I was absent one day, then I could just, right? Okay. All right. Moving on. On the do part, make sure you have this written down. I'm not going to grade you on your side work. The side work is just to help you out, okay? I'm not going to grade you on the grading this calculator part out. This was just to show you for notes. Yes. You don't have to show me this side work, but it's going to be helpful because you need it anyway, right? Okay, again, I said here, guys, no chatter, please, or it's going to pick it up here in the video. I need to see my chi-square work, though. So my chi-square work, this is definitely where you're going to want to use the dot, dot, dot. Take the first cell of my observed. So my first cell of my observed is right here, 55. 55 minus 77.56 squared over 77.56. Observed minus expected squared divided by expected. Plus, maybe take the second cell. My second cell is right here, 76. So plus 76 minus my expected 53.44. Squared divided by 53.44 plus dot, 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 plus the last cell. Okay? Ladies and gentlemen, the last cell is 394. Minus, what's the expected for 394? Is it like 600 something? Or 421? 421.86. Something's going on with my smart board, sorry. Divided by 421.86. Yep, I did the first two cells plus dot, 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 the last cell. You just have to show a little bit of work to say, hey, I'm not just a number cruncher. I actually know what these values are doing. Yes.
Is it okay if you were to do it in a different order? Like if you were to go.
Totally. Totally okay.
It's 0.81.
Okay, 0.81. Thank you, Ash. You just have props on the video. Okay. And then our chi-squared value is right here on my side work, and that's okay if you just have it that way. Our p-value, we already said here, is 0.0006. Is it okay to have a scientific notation? No, absolutely not. You do have to show it in decimals. And then our degrees of freedom are 2. You do not need to show your work on the degrees of freedom, but ladies and gentlemen, you do need to know for the multiple choice exam, how do I get the degrees of freedom? R minus 1. What does R stand for, would you think, when we're dealing with a matrix?
Rows.
Yes, your rows minus 1 times columns minus 1. Okay? Rows minus 1 times column minus 1. Okay? The rows are like across, the columns are up and down. Just verify, no big deal. So now let's go to our conclusion. Our conclusion, what are we going to do, guys? Because our p-value is low, is approximately 0.00006. We what? When the p-value is low, we reject the HO. Yes, it's all your conclusions will always be the same. Oops. We do have alpha. Oh, so I probably should have said what? Which is, I know, less than alpha equal to 0.05. We reject H naught. What do we have evidence for? Yeah, we have evidence to support, and then just take your HA and rewrite it. So I'm going to take HA, and I'm literally going to Control C. And then I'm going to Control V. Oh, that doesn't look clean, does it? Let's do that. Okay, so write that down. Question. Yeah, we don't have, no, we always say we reject H no or we don't reject HO based on the p-value. So since our p-value is less than alpha, we reject H naught. Then we always say we have evidence for HA or don't have evidence for HA. So the decision is always about HO, whether we reject or fail to reject. And then the evidence is always for or against HA. So that's how the two sentences always work. Excuse me. Now you may be asked for a follow-up analysis, and then you would just, in this case, we don't have the CNTRB button, okay? We don't have the CNTRB button. So then we're just going to look at the differences, and which one do we think contributed the most to chi-square? Do I need to cover this step with you, or have I talked enough about follow-up analysis? Okay, what I do want to cover with you, though, is this question here. Now, let me pause for a second. Can you guys look at me real quick? Do you guys all have the conclusion down? Like, am I going too fast for you? Okay, we're good? Okay, please write this down now. What other tests could we do to confirm our results? This is something I definitely want you to have a connection to. And it's part of the curriculum as well. So what type of variables do we have here? We have what campus you're going to and how often you use Facebook. These are what type of variables? Are they categorical or are they quantitative? Okay, they would be one of each if I asked how many hours are you spending on Facebook. But I'm asking, like, it's a category, like it's once a day, once a week, or once a month, okay? So, and you're answering like yes or no to them, okay? If I said hours, it would be quantitative, but these are all categorical variables. And when we go to categorical variables, we can make proportions. So what we could do instead is we could do a two-proportion hypothesis test. We could look up here, we could say, hey, H naught is the proportion of people from the main campus that use it monthly is equal to the proportion of the Commonwealth that uses it monthly. And goodness if it just does it, it's a two-tail when you're thinking about it as a proportion test. And then I would say HA, the proportion, okay, the proportion of the main campus that uses it monthly is not equal to the proportion of the Commonwealth that uses it monthly. Now we're going to investigate that, so I'm going to ask 3 different rows to help me out with this. I'd like everyone right now to go to a 2-proportion z-test for me in your calculator. Everyone's going to a 2-proportion z-test in your calculator. And I'm going to ask separate rows to do separate things. Does everyone have this one written down here? The HOHA, and again, my board is kind of messed up, so it looks a little sloppy. I'm sorry. Two proportion z-test. Okay. In your two proportion z-test, this first row, okay? I'll do it in blue because we haven't used that. You are going to look at the proportion of people from the main campus versus the Commonwealth, using it several times a month or less. So your X1 is 55, your N1 is 910, your X2 is 76, your N2 is 627. These two rows, and it's a not equals test, okay? These two rows, you're going to do at least once a week. So your X1 will be 215, your N1 will be 910, your X2 will be 157, your N2 will be 627. And then the last two rows, you're going to look at a proportion test at least once per day. So X1, X2, N1, N2, okay? So do a two proportion z-test for me, please. And we're going to investigate the p-values over here. So our p-value for this first one is 0.00005. So what would we say about the proportion of people at the main campus versus the Commonwealth? We have evidence that they're what? Yeah, that they're not equal, that the proportions are different of people using it several times a month at main campus versus Commonwealth. These two, what was your guys' p-value for these ones? 0.52. Yep, the p-value here is 0.5249.
Is the H not, is the H not equal or not?
Yeah, it's always H not if the two are equal. So we assume they're equal, and now we're saying for once a week, are they different? And what do we find? They're not different. The people at the main campus versus the Commonwealth, the proportions are not significantly different. Okay, now what about the last one? What did you guys get for a p-value over here?
Over here, 0.002.
I'm sorry. So our chi-squared test is trying to see, is there a difference across the board? And our chi-squared test says yes. But our two proportion z-test says what? It says yes for two of them, and one of them it says no.
Wait. The smaller numbers on those nodes, there's not a
Yep, so we have two of them where we say there is a difference. We found that there's a difference between them. Because we always assume they're the same. So in this test right here, right, we say there's the same, okay? With a proportion. We're saying the proportions are the same. Let's see if they're different. And we see that they're different. For this one, we assume they're the same. Let's see if there's different. The p-value is so high, they're not different. For this one, we assume the proportions are the same. They're not the same.
I thought the p-value was really high.
No. It's okay.
P-value is low. Reject HO.
All right. Okay. What I want to tell you, ladies and gentlemen, is we have a contradiction. And that contradiction is saying the chi-square test is saying the distribution of the main campus versus the distribution of the Commonwealth is different. But our two proportion z-tests for three of them across the board, only two of the three say they're different. And in AP Stats, what we say is in a two proportion z-test with the three different categories, if two of the three are significantly different, it confirms our results from our chi-square test. There will be one question in your homework over that, so if it went a little over your head, don't worry. Your main goal is you understand the chi-square test for independence, meaning you understand that state, plan, do, conclude. How to use the calculator, how to get your expected cell counts. If you haven't glued your computer output in, I just want to quickly talk about what each one means. You need to understand a computer output. You will be getting one in your multiple choice exam, I guarantee. Again, I just want to repeat, if you did not understand that last part, you'll get one problem in your homework to worry about it. It's not the biggest concern to me right now. What the concern for me is that you understand the state, plan, do, conclude. You can follow your steps in your notebook and you know what to do. Am I okay to move on? Okay. The computer output. I just want to quick note what each of these are. We have data. The blue highlighted is your observed values. Your pink highlighted is your expected values. And then this is actually your contribution. So my guess is if you are asked on the AP exam or on a test from me or in the homework. Again, guys. If you are asked a follow-up exam or follow-up analysis in the homework, you're going to want to look at the contribution. This is the contribution to chi-squared. These are the individual chi-squared values. And when we add up those values, it gives us the total chi-squared statistic, which is equal to 58.394. So when I add up 31 plus 7 plus 16 plus 3, I get 58.394. My guess is this will be used for follow-up analysis where you need to look at 31.66 and say the number 2 and opposes, that's my biggest contribution to chi-squared. I just want to make sure you know what each digit or what each number means. These are your individual components for chi-squared. When you add up these values, it makes up your total chi-squared statistic. Okay, your total chi. So this is called your chi-squared value, like individual component value. When you add them up, it makes that chi-squared statistic. And your follow-up analysis would be which one is the highest contribution or the largest component, and there you can answer it. I'm done. You can look on Schoology. Have a good weekend. Have a happy St. Patrick's Day. Is anyone Irish in here? Just one? Just one? All right, you guys.